Welcome to another enlightening lesson in our Number Concepts and Operations series. In this video, we're taking our understanding of factors, multiples, highest common factors, and lowest common multiples to the next level. We'll not only learn how to calculate them but also see how these concepts are applied in various mathematical and real-world scenarios. Let's begin with a quick review of factors and multiples. Factors are numbers that divide another number without leaving a remainder, while multiples are numbers obtained by multiplying a given number by whole numbers. Understanding these concepts is crucial as they form the foundation for HCF and LCM calculations. We'll delve deeper into calculating the highest common factor of natural numbers. We'll explore various methods, including prime factorization and listing factors, to find the HCF effectively. You'll also see how the HCF simplifies fractions and aids in problem solving. One method is prime factorization. This involves breaking down the numbers into their prime factors and identifying common prime factors. Let's find the HCF of 56 and 48 using prime factorization. We need to write each number as a product of its prime factors. This process allows us to break down a number into its most basic building blocks, which are prime numbers. Start by dividing 56 by the smallest prime number, which is 2. Now, you have a quotient of 28. Continue to divide 28 by 2. Keep dividing by 2 as long as you can. Once you reach a point where you can't divide by 2 anymore, move on to the next smallest prime number, which is 3. But in this case, 3 does not divide into 7, so we move on to the next prime, which is 5. 7 is a prime number itself, so we cannot divide it any further. Now, let's write down 56 as a product of its prime factors. 56 equals 2 times 2 times 2 times 7, or 2 to the power of 3 times 7. To find the prime factorization of the number 48, start by dividing 48 by the smallest prime number, which is 2. 48 divided by 2 equals 24. Now, you have a quotient of 24. Continue to divide 24 by 2. 24 divided by 2 equals 12. Keep dividing by 2 as long as you can. 12 divided by 2 equals 6. Continue to divide by 2. 6 divided by 2 equals 3. Once you reach a point where you can't divide by 2 anymore, check if the quotient is divisible by 3. 3 is a prime number itself, so you can't divide it any further. Now, let's write down 48 as a product of its prime factors. 48 equals 2 times 2 times 2 times 2 times 3 equals 2 to the power of 4 times 3. The common prime factors are 2, 2, and 2, or simply 2 to the power of 3. So, the HCF of 56 and 48 is 2 to the power of 3, which equals 8. Understanding the HCF is particularly useful when working with fractions. The HCF of the numerator and denominator can be used to simplify fractions. For instance, if we have the fraction 24 over 36, we can find the HCF, which we calculated earlier, as 12. By dividing both the numerator and denominator by 12, we simplify the fraction to 2/3. This simplification makes calculations with fractions easier and more manageable, both in everyday life and more complex mathematical problems. Next, we'll tackle the lowest common multiple. LCM is a key concept in solving problems involving time, distance, and other real-world scenarios. The LCM of two or more numbers is the smallest number that is a multiple of each of those numbers. One efficient way to find the LCM is by using prime factorization. Let's find the LCM of 12 and 18 using prime factorization. Prime factorization of 12 equals 2 times 2 times 3 equals 2 to the power of 2 times 3. Prime factorization of 18 equals 2 times 3 times 3 equals 2 times 3 to the power of 2. Now, identify all the unique prime factors and the highest power of each factor. Unique prime factors are 2 and 3. Highest power of 2 is 2. Highest power of 3 is 2. To find the LCM, multiply all the unique prime factors with their highest powers. LCM equals 2 to the power of 2 times 3 to the power of 2 equals 4 times 9 equals 36. So, the LCM of 12 and 18 is 36. When dealing with more than two numbers, you can extend this method. For example, to find the LCM of 6, 8, and 12, you can express each one as a product of its prime factors. Prime factorization of 6 equals 2 times 3. Prime factorization of 8 equals 2 times 2 times 2 equals 2 to the power of 3. Prime factorization of 12 equals 2 times 2 times 3 equals 2 to the power of 2 times 3. Now multiply all the unique prime factors with their highest powers. LCM equals 2 to the power of 3 times 3 equals 8 times 3 equals 24. We'll apply our knowledge of factors, multiples, HCF, and LCM to solve practical problems. These skills are essential not only for excelling in mathematics but also for making informed decisions in everyday life. Stay tuned for our upcoming lessons. If you have questions or specific topics you'd like us to cover, please share your ideas in the comments below. Thank you for joining us today. Please don't forget to like this video and subscribe to our channel for more math lessons.